Welcome back to the session. In the previous sessions, we have seen three different methods that we used to compute IBFS. So this method can be applied if the problem is of the standard type. The standard type of transportation is it has to be a balanced problem and it has to be a minimization case. Like we solved assignment problem. The standard form of assignment problem was balanced minimization case. Similarly, in transportation as well, the standard form is the balanced minimization case itself. But what if I have an unbalanced problem? When do we call a transportation problem to be unbalanced? Whenever in the given problem, the sum of the supplies is not equal to the sum of the demands, right? If the sum of the supplies, that is the last column, and sum of the demands, that is the last row sum, the last row sum and the last column sum, if it is not equal, then the problem is said to be unbalanced. So what is the process then? Obviously, when we have an unbalanced problem, we will have to bring it to standard form. Only then the solution methods can be applied. So we will have to convert this unbalanced problem into a balanced problem. If the problem is unbalanced, it has to be converted into a balanced problem by adding dummy row or dummy column as needed. So when do we add dummy row or when do we add dummy column? We will just have a look. If the supply or the capacity total is less than the demands, then we will have to add a dummy row with the difference as the supply. So whatever is the difference value, that has to be taken as a supply for that particular row, and we will have to balance it. If the demand total is less when compared to the supply totals, then we will be adding a dummy column, and whatever is the difference will be the demand for that particular column, so that the totals will match, so that the totals will become equal. In the dummy row or column, all the cost matrix elements, so the cost per unit transportation has to be given. So like in assignment problem, here also the cost matrix will be considered 0 until and unless it is exclusively specified in the problem. Okay. So if at all we need to understand this process, we will consider one problem and try to solve it. So by looking into the solution procedure, you will be able to understand the problem better. Okay. So we'll consider a problem now. So the problem that I've taken is obtain the initial basic feasible solution of the transportation problem using NWCR and LCM. I will be solving it in both the methods so that you would be able to understand it better, whose cost matrix is as given below. So how do we get to know whether it is balanced or unbalanced? First, try to take the sum of the supplies. 100 plus 75, 175, 175 plus 50, 225, 225 plus 75 is 300. The supply total is 300. Coming to the demands are 70, 70 plus 80, 150, 150 plus 120 is 270. So here the demand is 270, the supply is 300. The totals do not match. Therefore, the problem is unbalanced transportation problem. So we will have a look at it. Since summation AI is equal to 300 and summation BJ is 270, the problem is an unbalanced transportation problem. Because the demand total is less, we will have to add a dummy column, right? We will have to add a dummy column. Therefore, the difference between the totals 300 minus 270 is 30. So for that dummy column, the demand will be placed as 30. Okay, hope you have understood. Insert the dummy column with the demand 300 minus 270 is equal to 30. And the cost per unit, right? That has to be considered as zero because in the problem they have not specified anything exclusively about the cost of the dummy column. Therefore, we will be taking it as zero. So now my transportation problem has four origins O1, O2, O3, O4 and three destinations D1, D2, D3 and the dummy destination DU. And the cost matrix is 5, 6, 9, 0, 3, 5, 10, 0, 6, 7, 6, 0, 6, 4, 10 and 0. And we have seen the supplies will be 100, 75, 50, 75 as given in the problem itself. And the demands will be 70, 80, 120 as given in the problem and 30 being the dummy demand. Now we'll try to solve this problem using NWCR. So northwest corner is the top left 1, 1 position. So how much can be satisfied here? Demand is 70, supply is 100. So I can satisfy 70. So supply becomes 100 minus 70 equals 30 and demand becomes 70 minus 70 equals 0. So at 1, 1, I have made an allocation of 70 units. And this column, I'll just take a highlighter. And this column gets cancelled. Now the remaining matrix is this. In this top left corner is at 6. So here the supply is 30, demand is 80. So I can satisfy 30. So the supply becomes 30 minus 30, 0. Demand becomes 80 minus 30, which is 50. So at 1, 2, I make an allocation of 30 units. So this column is gone and this row is gone. Okay. Now the remaining matrix is 5, 10, 0, 7, 6, 0, 4, 10, 0. So the top left corner is 5. So I need to make an allocation here. Supply is 75, demand is 50. So I can satisfy 50. So demand becomes 50 minus 50 equals 0. Supply becomes 75 minus 50 is equal to 25. So my allocation is at 2, 2 with 50 units. So this row is gone, this column and this column is gone. Now the remaining matrix is 10, 0, 6, 0, 10, 0. So the top left corner is 10. So here the supply is 25, demand is 120. So satisfy 25 here. So supply becomes 25 minus 25 equals 0. Demand becomes 120 minus 25 equals 95. So I make an allocation at 2, 3 with 25 units. So the first row is gone. The second row is gone. First column is gone and the second column is gone. So now the matrix that I'm remaining with is 6, 0 and 10, 0. Top left corner is 6, supply 50, demand 95. So I can satisfy 50. So supply becomes 50 minus 50 equals 0. Demand becomes 95 minus 50 equals 45. So I make an allocation at 3, 3 with 50 units. Okay. So the first row is gone. Second row is also gone. Third row is also gone. First column is gone and the second column is gone. Now the matrix that I'm remaining with is 10 and 0. So the demand at 10 is 45, supply is 75. So I can satisfy 45. So make an allocation of 45 at 4, 3. So I make an allocation at 4, 3 with 45 units. So now the first row is gone, second row is gone, third row is also gone, first column is gone, second column is gone, and the third column also is gone. Now I'm left out with only a single cell 0. So as I've already told you, whenever there is a single cell remaining, the supply and demands will match. So the supply is also 30, demand is also 30. So satisfy this at 4 comma u, I make an allocation of 30 units so that this row and this column also gets cancelled. Fine. At 4 comma du, I make an allocation of 30. So now next job is calculating the transportation cost. The transportation cost will be 70 into 5 plus 30 into 6 plus 50 into 5 plus 25 into 10 plus 50 into 6 plus 45 into 10 plus 30 into 0. So 70 into 5 is 350, 30 into 6 is 180, 150 into 5 is 50 into 5 is 250, 25 into 10 is 250, 50 into 6 is 300, 45 into 10 is 450, and 30 into 0 is 0. When I add up all these values, I get the total transportation cost TTC of IBFS as 1780, 1780. So let me solve the same problem using LCM or the least cost method. So for the least cost method also, the procedure is the same. There is a mismatch in the totals. So I need to add a dummy column with the demand 30. And then I will start applying the LCM. So here, first I am supposed to look for the least cost. The least cost is 0, which is available in the first row, second row, third row, and fourth row as well. There is a tie. So you can pick any one arbitrarily. So what I do is I pick it in the first row itself. So that the supply is 100, demand is 30. So I can satisfy only 30. Wherever you take, you will be able to satisfy only 30. Fine. So the demand is 30. So demand becomes 30 minus 30 equals 0. Supply becomes 100 minus 30 equals 70. So I make an allocation at 1 comma du with 30. 1 comma du 30. So this column is gone now. So I am left out with the residual transportation matrix or cost matrix. In this I am supposed to find the least cost. The next least cost was 3, right? So I need to make an allocation here. So how much will be the allocation? Demand is 70, supply is 75, minimum is 70. So I can satisfy 70 units. So I make an allocation at 2 comma 1 with 70 units. Supply becomes 75 minus 70 equals 5. Demand becomes 70 minus 70 equals 0. So the allocation is at 2 comma 1 with 70 units. So this column is gone and this column is also gone. Now I am left out with this residual cost matrix. In this, the least cost is 4. So I need to make an allocation here. So how much allocation can be made? Supply is 75, demand is 80. So minimum is 75. So I can make an allocation at 4 comma 2 with 75 units. So supply becomes 75 minus 75 0. Demand becomes 80 minus 75 5. Okay. So the allocation that I have made is at 4 comma 2 with 75 units. 4 comma 2 75 units. So now the first column is gone, second column is gone, and the fourth row is gone. Now the remaining matrix that I have is 6, 9, 5, 10, 7, 6. So the least cost amongst this is 5. So here I am supposed to make an allocation. So what is the allocation? Supply is 5, demand is 5. So satisfy that 5. So at 2 comma 2, I make an allocation of 5. Supply becomes 5 minus 5 0. Demand becomes 5 minus 5 0. Okay, so let's have a look. This column is gone, this column is gone, this row was already gone, and this row is also gone. You remember, whenever there is a tie, I'm not supposed to cancel both the row and the column. So either the row or the column has to be crossed off. I crossed off the row. So the remaining matrix that I have is 6976. So the least cost is 6. I have it here, but I cannot satisfy because the demand is 0. I can satisfy here because there is a demand as well as a supply. Right? What is the supply? Supply is 50, demand is 120. So I can satisfy 50. So my next allocation will be at 3, 3 with 50 units. Supply becomes 50 minus 50 equals 0, and the demand becomes 120 minus 50 equals 70. So the allocation is at 3, 3 with 50 units. Okay, so this column is gone, this column is gone. Now this row was gone. Now this row is also gone, and this row is also gone. My least cost is between 6 and 9. So at 6, I cannot make an allocation because the demand is 0. So I can make an allocation only at 9. So virtually it is as if this also is cancelled. I am remaining with the last cell. So whenever I am remaining with the last cell, the supply and demand will match if at all I have solved it correctly. So the supply is 70, demand is 70. So it is matching. So I can make an allocation of 70 at 1, 3. So supply becomes 70 minus 70, 0. Demand becomes 70 minus 70, 0. So this row and this column both gets cancelled. I'm left out with the last allocation that I get is at 1, 3 with 70. Okay, 1, 3, 70. What are the next task? Finding the total transportation cost TTC. So TTC is 70 into 9 plus 30 into 0 plus 70 into 3 plus 5 into 5 plus 50 into 6 plus 75 into 4. So 70 into 9 is 630, 30 into 0 is 0, 70 into 3 is 210, 5 into 5 is 25, 50 into 6 is 300, 75 into 4 is also 300. So when I add up all these values, I get 1465, 1465. When you compare it with NWCR, NWCR gave you an answer of 1780. Here I've got 1465. So in this case, LCM is giving you a better solution than NWCR. Okay. Hope the concept is understood. Whenever you have an unbalanced problem, based on the totals, you will have to decide whether to add a dummy row or a dummy column with the difference in the totals as the demand or the supply. Thank you for your patient listening. Hope you have understood. If at all you have any doubts, you can just post it on the classroom platform. Thank you.